Okay, today we're talking about the special relationships that happen between the angles that are formed by lines and transversals. What special relationships happen when those lines are parallel? So today the lines are going to be parallel. So look at this scenario. We learned that when we have two lines that are cut by a transversal, 4 different types of angles are formed: alternate interior, so like 4 and 6, same side interior, 4 and 5, corresponding, like 4 and 8, like alternate exterior, like 1 and 7. So notice, line A and line B are not parallel, and it looks like angle 1 looks like it's acute, angle 5 looks like it's obtuse, angle 2 looks like it's obtuse, 6 looks like it's acute. So like when these two lines are parallel, like there doesn't really seem to be a relationship between like the measure of the angles up here and the measure of these angles down here. So like this angle 1 and angle 5 are corresponding, but it doesn't really seem like they have any sort of like it doesn't seem like they're the same, or it doesn't seem like they have any special relationship. Whereas now it appears like line A and line B are parallel. They look like they're both horizontal. So then this appears, angle 1 and angle 5 look like they're going to be congruent. Angle 2 and angle 6 look like they're congruent. So notice there's a difference between the angles when the lines are not parallel and when the lines are parallel. So, first off, how do you know from a diagram that two lines are parallel? So, in this scenario, I could either spell it out for you. I could say line A is parallel to line B. Another way is with this symbol. It's like two parallel lines. So like I could say line A is parallel to line B, or sometimes they're just straight up and down. Line A is parallel to line B. That's another way. But look for that symbol. Or you might see an extra arrow, like a thick arrow that's like filled in on both of the lines. Something like that. Like if they both have a big fat chunky arrow on them, that's trying to tell you that they're parallel. Or another way it might look is it might be like some double arrows like that. Oh, and then my touch screen's not working. This is brutal. Something like that. Oh, the struggle is real. Why won't it work? Anyways, something like that. That took entirely too long. But notice these arrows are on the line as opposed to at the ends of the line. So you can't just assume that two lines are parallel. That you can't just assume like, oh, they look parallel, they definitely are parallel. Either look for some sort of statement that's communicating that the lines are parallel, or look for the arrows on the diagram. So hop on over to your foldable. The first theorem that we're going to learn about is called the alternate interior angles theorem. And what this means is when those two lines are parallel, when they're marked with arrows, or I'm telling you specifically when those two lines are parallel, our alternate interior angles are going to have a special relationship. When the lines are parallel, and only when the lines are parallel, alternate interior angles are congruent. Alternate interior angles are congruent when those lines are parallel. So, if I tell you line A is parallel to line B, something like that, you can say that the alternate interior angles like angle 4 and angle 6 are going to be congruent. And then is their alternate interior, and then like angle 3 and angle 5 are going to be congruent. So when the lines are parallel, when those two lines are parallel, the alternate interior angles are congruent. Okay, next one, alternate exterior angles theorem. The alternate exterior angles theorem says when those two lines are parallel, and only when those two lines are parallel, our alternate exterior angles are also going to be congruent. They're also going to be congruent. So alternate interior angles are congruent, alternate exterior angles are congruent. So if A is parallel to B, then angle 1 and angle 7 are going to be congruent, and angle 2 and angle 8 are going to be congruent. So alternate interior angles are congruent when those lines are parallel. Alternate exterior angles are going to be congruent when those lines are parallel. The corresponding angles, that should say postulate. Corresponding angles postulate. Whoopsies. Nice fix. Corresponding angles postulate says that when those two lines are parallel, and only when those two lines are parallel, our corresponding angles are also going to be congruent. So if I told you A was parallel to B, we could say angle 1 and angle 5 are congruent. We could say angle 2 and angle 6 are congruent. We could say angle 3 and angle 7 are going to be congruent. And we can say angle 4 and angle 8 are going to be congruent. The last one is the same side interior angles theorem. Same side interior angles theorem says when the two lines are parallel, the same side interior angles are going to be supplementary. Not congruent, same side supplementary. They all start with an S. Same side supplementary. Same side supplementary. And let's explore why that's true. Click, 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 click. Okay. Back to this picture. So we know that those lines are parallel. Let's say, I'm going to say angle 1 is 100 degrees. Measure of angle 1 is 100 degrees. Okay, angle 1 and angle 3 are vertical. And so that means angle 3 is also 100 degrees. And then angle 1 and angle 2 form a linear pair, which means they're supplementary, which means they add to 180. So angle 2 has to be 80 degrees. And then angle 2 and angle 4 are vertical, so then angle 4 is 80 degrees as well. Okay, we just learned about some special relationships when those lines are parallel. So when line A and line B are parallel, I know that my alternate interior angles are congruent. So angle 4 and angle 6 are congruent, so that means angle 6 is 80 degrees. And if angle 6 is 80 degrees, then angle 8 is 80 degrees. And if angle 8 is 80 degrees, and angle 8 and angle 5 form a linear pair, then angle 5 is 100 degrees, and angle 7 is 100 degrees. So if we're looking at our same side C, same side interior angles, these are not congruent, but they are supplementary. So 4 and 5 are supplementary, and angle 3 and angle 6 are supplementary. Click, 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 click. Okay, so if A is parallel to B, then angle 4 and angle 5 are supplementary. The measure of angle 4 plus the measure of angle 5 has to equal 180. And then also angle 3 and angle 6 are supplementary. The measure of angle 3 plus the measure of angle 6 equals 180. And those are our special relationships when the lines are parallel. Alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent, but same side interior angles are supplementary when the lines are parallel.